Okay, this is 3.4c. I'm doing example 6, bottom of page 294 in college algebra. And the first part of this says find the rational zeros and then the other zeros. That is, solve f of x equals 0. So what I'm looking for is my x values when y is 0. So, a couple things from just past videos in 3.4. I know that I have at most 5 zeros, and I also know that any rational zero must be of the form p of q, where p is a factor of 15 and q is a factor of 2. So what I do is I write all of my factors of p, so plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Then I write my factors of 2, plus or minus 1, and plus or minus 2. So, again, any combination, plus or minus 1, 1 half, 3, 3 halves, 5, 5 halves, 15, 15 halves, plus or minus. So those are all the possibilities for p over q. In fact, in the solution on page 235 at the top, it says possibilities for p over q, 1, negative 1, 3, negative 3, 5, negative 5, etc. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different possibilities for factors of my function up here for me to try. Okay, so using synthetic division, the book tried, well, let's go ahead and put my options. I'm going to put, or my coefficients here. So those are my coefficients, and I have got to try each one of these options. So they tried one and it didn't work, and if you just look here real quick as we go through here, and as I add all these together, I get, obviously I'm not going to get negative 15 here to make this a 0. So I know that isn't going to work. And I go ahead and I try negative 1, and if you look in the book, when they tried negative 1, that does not work. And as they continue going, they try 1 half for right here, and they found out that it does work and gave me negative 15 and a 0 for my remainder. So 1 half worked, and that would give me, if I used 1 half, let's get rid of this here, I would have x minus 1 half as one of my factors. And what do I have left? Well, if I use the 1 half in there using my synthetic division, I get 2x to the 4th. Notice it's 1 less than this, and it always will be when I factored out an x minus something, minus 4x squared minus 30. Now I'm going to do synthetic division on that if I want to, but probably what I would do first, see, does the book do that? Yeah, the book does that, is I would factor out a 2. Okay, so that helps me out a lot, because now I can look at this. I can look at this a couple different ways. I can actually I'm just going to move that up a little bit. I can actually solve this because I've got an x to the 4th and an x squared. I can use x squared equals u and get u squared minus 2u minus 15. And I've still got my x minus 1 half. and then go from there to that, and obviously it's going to be a 5 and a 3, negative, positive, u, still have this other stuff on here, and then I can replace my u with my x squared. I still have my 2 and my x minus 1/2. Okay, and then I can solve. Let's push this up. I can solve for my x here and get a positive 1/2. I can solve for this and get a plus or minus square root of 5, because I'm going to get an x squared minus 5 equals 0, x squared equals 5, x equals plus or minus 5, the square root of 5. And then over here I'm going to get x squared plus 3 equals 0, x squared equals negative 3, x equals plus or minus the square root of 3i. So we only have one rational 0, and that's this one right here, 1/2. I guess I should put that down here as one of my zeros. So I have 1/2, and then I've got an irrational 0 here, and then I've got an imaginary number here, plus or minus the square root of 3i, and that actually needs to be the radical does not go over the I. It's just the square root of 3 and then the I. That won't erase there. So anyway, those are my options there. So if I want, those are my roots. So if I want to, like it says in B, it asks for the linear factors. I'm going to write this as 2. Nothing happened to that 2. I'm going to use that and get x minus 1/2. I'm going to use x plus the square root of 5, x minus the square root of 5, x plus the square root of 3i, and x minus the square root of 3i. Okay, so I have 1, 2, 3, 4, 5 answers, like I should be, because this was an x to the 5th power, and those are my factors. If I were to take all of these and multiply those, I would get my original equation back. Okay, so the top of page 296 starts talking about Descartes' rule of signs, and this is a way that we're able to find the number of positive real zeros and the number of negative real zeros of a polynomial function. Okay, so this is what we do here. When we look at a polynomial function like this, we look and see how often the sign changes from one term to the next. So for instance, if we look here, we have a positive sign, and here we have a negative sign. So we change from plus or positive to a negative one time. Then we change from a negative to a positive one time. And then we went from a positive to a positive. So we change signs in this polynomial function 1, 2 times. Okay? So do you see what's going on there? We look to where we changed the sign from positive to negative. Now this only works when our polynomial is arranged in descending or ascending order. So in this case it's descending 5, 2, 1, da 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 da. Or it could be ascending. It could start at the other end and go this way. Doesn't really matter. The constant term right here cannot be 0. If it is, it doesn't work. Okay, so we determine the variations of sign. So it varies. It changes from here to here once, from here to here once. So 2 changes total. Okay. Then what happens here is the number of positive zeros, okay, positive real zeros, is going to be the same as the number of variations, so 2, or less than this by a positive even integer. So meaning it's either going to be 2 positive real numbers for the answer, or it's going to be less than 2 by a positive even integer. So less than 2 by 2, so 2 minus 2 would give you 0, or it could be less than 2 by 2 or by 4, which would give you a negative 2. Well, there can't be a negative 2 number of integers, so that gets thrown out. So these are my possible choices of positive real number solutions. I'm either going to have 2 or I'm going to have 0. Okay, so I just lower the number by 2 at a time, and once I hit 0, I'm done. So if this number right here were a 6, then this number could be a 4 or a 2 or a 0. So you just go down by an even number or by 2, and it will give you all the other possibilities of real number solutions. Okay? So, negative real number solutions. How do we decide if there are any negative real number solutions? Okay, so these are positive real number solutions. How do we determine how many negative real number solutions? Well, we look at the same polynomial function, but instead of finding the p of x, we're going to find the p of negative x. So that gives me 2 times negative x to the 5th minus 3 times negative x squared plus negative x plus 4. So we just stick a negative x in there whenever we see an x. And we get negative 2x to the 5th minus 3x squared minus x plus 4. Now we look at the variation. So from here to here, there was no change, so that doesn't count. Here to here, there was no change. Here to here, there was 1. So the possibilities of a negative real number is going to be 1, or again, it could be 1 minus an even number. Well, the smallest even number is 2, so 1 minus 2 would make this negative 1, and since you can't have a negative 1 number of answers, that's not even a possibility. Okay, so you have a choice of just one possible solution there. So although positive, we could have 2 real number solutions that were positive, or 0 real number solutions that are positive. For the negative, we don't have any other options except 1. So when this is 2, this is 1. When this is 0, this number here also has to be 1. We cannot have any more or any less real number solutions than the number of times this changed, because we can't reduce this 1 by an even number, because if we do, we go into the negative range, which we can't do. So that means there's only one possible answer that's going to be a negative real number, 1. So when we have 2 positive real numbers, we have 1 negative. If we were to have 0 real numbers positive, we're going to have 1. Well, this number up here is a 5. If you had 2 and 3 here, you do not get 5 here. If you had 0 and 1 here, you do not get 5. I have to have 5 answers. So this represents positive real number solutions. This represents negative real number solutions. That leaves me with non-real solutions. So if this is a 5 and I have 2 positive and 1 negative, then I can have 2 non-real solutions. If here I have 0 positive and 1 negative, then this number here, I have 4 non-real solutions. So, those are my choices of real number solutions here. Either 2, 1, 2 or 0, 1, 4. Okay, well let's look again, and all we're interested in doing is finding out how many real solutions, how many negative solutions, and how many non-real solutions we're going to get. So this is example 9. So let's look at our variation in sign. We have 1 there, we have 1 there, we have 1 there, and we have 1 there. So we have 4 variations in sign. So the number of positive real number solutions are going to be 4, which is what we have there, or 4 minus 2, or 4 minus 4. Those are our options. Real number positive real zeros are either going to be the number of changes or the number of changes minus 2 and minus 4 until we get all the way to 0. So this time it's 4, 2, or 0. Okay, let's look at the number of negative real number solutions. So let's put in I'll do this in green here. Let's look at p of negative x. So that's going to give me 5 times negative x to the 4th minus 3 times negative x cubed plus 7 times negative x squared minus 12 times negative x plus 4. Okay, let's go ahead and distribute that negative there, and we get 5x to the 4th plus 3x cubed plus 7x squared plus 12x plus 4. Okay, let's look at see how many changes we have. Positive to positive, positive to positive, positive to positive, positive to positive. We have no changes in sign at all through this whole thing. So we have, as far as negative real number solutions, our options are 0, 0, and 0. We don't have any. They don't exist. So let's look at non-real. Non-real. Well, we have a 4 up here, so that means the sum has to add up to 4. Well, we have 4 there, so this is going to be 0, this is going to be 2, and this is going to be 4. So my possible factors, I'm going to have 4 that are positive real numbers and then nothing else. 2 real numbers, 2 non-real or imaginary, or no real and all of them be imaginary. So it's going to be one of these columns or the other. It can't be this column and this column. You're either going to get this option, or this option as far as possible solutions. Okay, this is example 10, and it's a little bit different because one of the rules was that the last number needed to be a constant term that wasn't 0. I don't have a constant term. Anything with a variable keeps it from being a constant. If this said plus 5, then it would be a constant, but I have an x in each of these 3. So let's say that I factored out the x. Okay, that's a 5. Now I have a constant term. So I can look at this part here and determine how many zeros I have. I know that one of the polynomials has, it does have a polynomial or a factor with a 0 in it because I know x is going to be 0 there. because this is going to be equal to 0. So if I make that 0, it makes everything 0. So I know that's going to be one of my zeros. 0 is a 0. And then I've got this factor here. And so, see how many times it changes. It changes in sign from here to here. And that's the only place. So one time it changes. So that means positive real numbers. I have a choice of 1. Okay, that's my only choice. Negative real numbers. Let's put in a p of negative x. That's going to give me 6 times negative x to the 5th power minus 2 times negative x minus 5. Okay, and I go ahead and distribute that, and I get negative 6x to the 5th power plus 2x minus 5. Okay, so now we look at changes. I've got a change there, and I have a change there. So I have 2 changes. So I have a possibility of 2 negative real numbers, or 0, because 2 minus 2 is 0. Well, on my plus, I only have 1 or 1. I can't change that. And then negative, or I'm sorry, non-real, I have a choice, because this has to add up. I have a choice of 3 or 5, because those have to add up to 6. And that tells me how many of those non-real numbers I get for my solution. So, that's how you do this lesson, Descartes' rule of signs.